Hi, good morning everybody. I want to present you guys Dr. Salvador Lluch-Cota. He obtained his PhD from the Universidad Autónoma de Baja California Sur, which is the State University of Baja. He has been a researcher in the Research Center of Biological Sciences of the Northwest, which is known as CIBNOR, for 15 years. He has been involved in the International Biosphere-Geosphere program and served as a leader author of the Intergovernmental Panel of Climate Change, the IPCC, of the Oceans chapter during the 5th assessment report. He also has served as president of the Mexican chapter of the AFS, where I had the opportunity to meet him and his research. And his current work and research has been recognized internationally for its important contribution and issues related to climate change in the Gulf of California. So please welcome him.
Thank you. Thanks a lot, and thanks for the opportunity of being here and talk to you. I'm very pleased that last time I was here I was thinner, younger, and I probably didn't use glasses back then. So it's good to come back. What I'll do is I'm going to talk to you about general aspects of climate change and fisheries, just to let you know or try to transmit to you how uncertain we are about this relation and all it implies, and hopefully give you a message. This is a very challenging public for me to talk to, because you're mostly in the management, political sciences and law topics, and that's not my specialty, but I think it's a beautiful occasion to talk particularly to you about this topic. So first of all, let me start with this. If one looks at this, you've probably seen this picture hundreds of times. It's come from the FAO reports. If you see this graph, this is the fully exploited fisheries in the world. So one could think that everything is perfect, because the number of fully exploited populations is relatively stable, and the overexploited populations and depleting, recovering populations are not really increasing dramatically, and the number of underexploited populations is decreasing. That means we're getting better at exploiting fisheries from the ocean. So it could look like a story of success, but of course that's not what we should be looking at. The problem is, the basic problem, or the most, the thing I want to transmit right now, the problem is that fishery collapses and failure stories of management occurs in many places of the world, including some of the areas where the most sophisticated management strategies and more tradition in management has been occurring. So this means that we're not doing very well, and that increasing the science and the data is not enough. And the good thing is that there seems to be, this is the only slide with the long text that I'm going to use, but I really didn't find a way to shorten even further this part of Hilburn's chapter that transmit a very important idea, that it's that fisheries management has been failing, and we've seen, or we tend to think that it is because of overfishing, and that we propose a scientific society, that the solution is precautionary approach, marine protected areas, and ecosystem management. And he demonstrates it in his paper, some cases of ecosystem approach management totally failing. I would say that the precautionary approach is basically recognizing that we don't know, and then probably losing the opportunity of getting more protein from the sea because of the lack of knowledge. And marine protected areas, there are also many examples of failure, basically because of the way they have been designed in the past, some of them at least. And the real problem is that everyone wants to fish and everyone wants to get into it. And he's very optimistic, and I tend to agree with him that there are few examples of potential routes to go and improve management. One of them has been demonstrated in this graph by one of the faculties here, my friend. The ITQs, and also rights-based, and I would say upon that the incentive-based strategy is also probably providing some help. However, again, that's not the end of the story. One of the problems is that we know that several fishery collapses are not related, only related to the fish exploitation or the fishing effort, and we know there are populations changing independently or upon the fishing effort. We know that from many years ago, this was a very interesting scientist. This is not his picture, but this is how I think he looks like. But in the late 80s, he analyzed the herring in North Europe, and he detected a 55 cycle in the abundance of this species, of this fishery, and he proposed that it was related to climate and sunspots. I have to say that most of the mathematical improvements and sophistication of the fisheries management occurred after that, even when we already knew something in the climate was affecting the populations. We tend to forget about it and complicate our computations and so forth. Also, by a lot of different evidences from non-exploited populations, as the Russell cycle in the English Channel, and right now in the literature there's familiar anthropological, paleoecological, and a lot of empirical correlations between climate and different fisheries. Of course, even fisheries going back in time, these are time series from off here in the Santa Barbara Channel from sardine scales, demonstrating, people argue about these graphs, but they somehow demonstrate huge fluctuations even way before the industrial fishery began. Upon that, that's the new fashion and the new problem we're realizing. That's the warming trend in the global world temperature, ocean and air. There's a warming trend that we're calling climate warming or global warming or climate change. That's upon the typical natural variability that we already were trying to understand in Chirano, like ENSO and so forth, and others like the North Pacific Oscillation, that it's very, very well studied for some of the resources in the North Pacific. And the problem is that we are partially unable to fully understand the decadal oscillations and so forth and the linkages to natural populations because our time series are so short. So with climate warming or climate change, it's even worse. We don't fully understand the relations and the potential impacts. Some observations so far, so observations coming from field, from lab, and from modeling, support that ocean warming will change the overall biomass. For example, in some places they have witnessed this kind of changes that increasing temperature reduces the biomass of phytoplankton and other groups. Loss of habitat, such as coral reefs, probably the best documented case. Changes in community composition and species richness, for example, like these observations also in the North Atlantic, a shift between the northeast and northwest in the composition of small versus large phytoplankton. These kind of observations are relatively common these days. Changes in geographical ranges of species. There's been a number of studies documenting northward shifts of several species, especially in the North Atlantic. Alterations of phenology and frequency of events. This is probably the hardest to document and understand in the ocean. For the terrestrial people, it's easier to document in some cases. In cases like ours, we're expecting things like these. This, for example, the differences between, this is the difference between future and present. So when they're strong, there's big differences. The sardine in the Gulf of California spawns in the winter, so between future and current winters, we see no differences. If models are right, and I'm going to talk about that, if models are doing a good job predicting the winds, what they say is that just after and before the winter, there are strong differences. So what we would be expecting is not a change in the temperature, in the winds inside the Gulf, but a change in the seasonal cycle, and that will probably be affecting a lot of the sardine spawning. Changes in connectivity, for example, these lab studies and demonstrating that at higher temperatures, the larvae development is faster, the survival decreases, and the dispersal, of course, decreases, even with different signals between species, but this kind of evidences. And increased propensity to change, including diseases and exotic species and so forth. There's further evidences, observations. Some observations of Oregon and California suggest that temperature increase will exacerbate stratification, in particular hypoxia, and the coastal influence of corrosive waters coming from changes in the distribution of this hypoxic layer in the ocean, and the new issue that is coming dramatically in the papers right now, in the literature, that is the absorption of CO2 by the ocean, and with the consequential change in pH and potential impacts on organisms. I must say that there are not enough evidences of the trends as a pattern for all the species. There are very contrasting observations and very contrasting results from the literature, and also very different spectrum for the experiments. Some of them using pH that are totally unacceptable for the climate people, but if they don't use them, they don't see strong differences or strong responses. So really the linkages between marine populations and ecosystems and climate change is nothing like this, nothing linear or easy to understand. It's more likely this LA freeway that we have to approach. And I'm going to talk now about why this happens. Why is so complicated? Part of it is that anthropogenic global warming is an ongoing debate, even if you agree or not, or what your position is. The truth is that it's an ongoing debate, particularly if the paleoclimatic and paleoecological people proposing different things, and so it's not totally solved, and that makes a lot of noise. And one of the evidences or ideas supporting the climate change is the scientific consensus, and this is one of the messages I want to transmit today, that at least in my mind, the scientific consensus should not be considered by all means an evidence of anything in science. By the contrary, most of the most important contributions in science came from how do you call that, upstream science, not going with the currents. So this is one important message. What your position is, or what you think, or how you approach climate change really depends on where you are in this circle. For for research, particularly natural research, science research, we should not take consensus or climate change for granted. We have to keep looking at evidences and contrast evidences permanently. That's our job. If we don't do that, we don't do our job. However, there are other sectors that they don't have that chance of being a skeptic or revisit ideas or analyze things permanently. They have to take decisions upon something. So their decision of believing or not this situation they have put us in the topic of climate change, they don't have an option. They have to take a position and make decisions and plans based on that. Similarly, conservation sector, including society and of course the producers. We all have to use the best available information, particularly facing a problem with the potential impacts that climate change has. Another problem is the short time series I mentioned earlier. I like to show this example because it comes from my PhD thesis. It was a fiasco from my thesis. Basically, I ended my thesis at the end of this trend, and I was very happy detecting a very clear trend in the climate signal in the Gulf of California, in the upwelling, particularly the differences between winter and summer. So the amplitude of the seasonal cycle of upwelling was really increasing, and I published that and everything. And I did, revisit the topic some years later, and this was my trend after some time. So the message here is that the short time series could give us a very wrong impression and lead us to wrong conclusions, and we have to know that. Another problems are the model limitations. I'm not getting into climate model limitations. There are several and very, very diverse, but even ecological models. This, for example, it's one of the best known and most respected models linking climate change to primary productivity on the ocean. And these areas with dots are the areas where the model fails. That means below 0.5 of accuracy. And I want to call your attention to the areas that basically cover all the most important fishing grounds in the world. So all conclusions or models we build upon the primary production to talk about fisheries will be carrying this uncertainty from the very beginning. So we're not very good at modeling the ecology so far. Another is the confusion factors, such as the influence of fishery itself. We want to forecast or predict fishery changes because of climate change, but we're also changing the rules by fishing at the same time. It's been demonstrated, for example, this change in the age structure of populations, increasing the sensitivity to climate change through and increasing the tight relation between the population and climate. For several cases, this has been especially the work of Globek and the global community. Another problem is the temporal and spatial heterogeneity of the signals. We tend to think that we have global warming, so I want to see my piece of ocean warming, and I get nervous if I don't see that. The truth is that this is, for example, the coastal of Eastern America, Western America, Eastern Pacific, and these are the trends, moving trends for 15 years for this coast through time. What it says basically is that there are periods of warming and cooling. So more red is more warm towards warming, and blue is towards cooling. They are not always homogeneous through the coast, and particularly that have been decreasing in some of these areas. And this is, again, some of the areas where we're most interested in terms of fishery. And so the message here is that we shouldn't be using the 2 degrees warming typical scenario from IPCC without looking at the regional signal. Another thing, of course, is that ecosystem complexity. I've seen this model of sardines and anchovy, a trophic model that didn't consider all the rest, very evident, strong linkages, and this is, of course, still a very crude cartoon of the ecosystem in pelagic ecosystem in Gulf, but it's way more complex that we can easily model. Also, rules change by itself in the ocean. Say, for example, in the Arctic, energy transfer going through krill in one ecosystem stage and going through capepods in another ecosystem stage. This also changing without, and we're not very able to forecast and model that change. It's just, we're just witnessing them. Another rules changing in the ocean, for example, the El Niño sound insulation working as the forest fires, firestorms in the land, resetting the ecosystem every certain number of years, as a secondary succession process for several areas in the ocean. We're particularly exposed to that. So rules are permanently changing, and again, we're not able to forecast those changes. And another issue is that we have probably oversimplified general patterns. We tend to think, for example, the general idea that diversity increases towards the tropics and decreases towards high latitudes, and that so we're sure that in the equator or climate equator we will find the higher number of species. The truth is that when we look at the temperature signal, that it's red, that's the annual average, and the blue one is annual amplitude. There are at least some groups like fishes that tend to distribute more accordingly to annual amplitude than to actually the temperature of the system. So this is of course ongoing work, and people is looking at different groups and changing the rules of macroecological principles like this that we use very easily and incorporate very easily or rapidly into our ecological models. So a summary so far: management improvement must consider climate variability, improvements and new ideas and new theoretical developments will be insufficient if they don't incorporate from the very beginning the considerations of fluctuations in the climate and in the populations. Potential impacts of climate change on marine ecosystems are very diverse and very hard to attribute. We can detect changes, but attribute them to global warming it's a different story. We have to be cautious. We have to try, but we have to be cautious in our conclusions. Some of the limitations to easily attribute our observed phenomena in the marine ecosystems to climate change include the fact that climate change itself is still an ongoing debate, that our time series are very short, that we have modeling limitations, huge modeling limitations, that we know climate change interacts, any way of climate change and even natural variability interacts with human forcing, such as fishing, that we have very different signals in different parts of the world, and so we cannot make general statements about trends, that the ecosystem is very complex. Sometimes its complexity makes it impossible to model, even to play with very simplified models. And we have probably oversimplified principles. I showed you one example, but there are a good number of examples of oversimplified principles that we're using to model climate change impacts. So the problem is that even if it's too hard, and now I'm not looking as optimistic as Hilmer did, but very pessimistic. However, one optimism window is that science really increases just before an IPCC report. So if you see this trend in number of papers dealing with climate change and in the ocean, you see that they show increasing trends for every IPCC report. That's because everyone wants to be mentioned in the IPCC report, which is understandable. The good news for us is that this very small increase for the last report will probably increase a lot because there's a new chapter in the IPCC reports dealing with oceans. So people is aware of that, and it's the number of reviews right now, it's increasing dramatically in many aspects. So we will see a very important increase here. The other thing to consider is that, do you remember these guys from the slide of who does what? This is our Secretary of Fisheries and Agriculture, and all that has something to do with food production in Mexico, and he's expecting for something to work with. So governments have to decide. Mexican government has a very strong position with climate change, taking climate change as a fact and acting as a consequence. So they have demanded a lot of studies, regional scales and sectorial studies to propose adaptation strategies. So even with all the uncertainty we have to do something and provide something. So I'm just showing a very fast, a small few slides about a project we are working with to propose adaptation plans from the industry and fisheries in Mexico, basically for 3 industrial fisheries and another one that somehow made it in the group. That it's a squid, sardine, tuna, and red grouper from the Atlantic. Basically, the construction is very simple. It's to build the adaptation plans. We're combining what we know about the resources, as much as we know about the resources and the climate change signal through sensibility. We're thinking on sensibility as how much the resource or the organisms respond to changes in the climate, whatever we can document in the past, and exposure that we're using climate change scenarios with a little twist that I'm going to show later. And we're combining that. Fortunately, we have a relatively recent, very strong effort in Mexico dealing with the fisheries plan, management plan for nationwide and for different resources that really took a lot of effort and a lot of people. And they ended with a number of strategies for each fishery aimed at this document. You can get it online. It's not very new, but still works. It was based on a very comprehensive diagnostic of each fishery, identification of problems, and an exercise of, how do you call that? It's strengths, weakness, opportunities, and threats, right? And put all the results in the context of different external frameworks, such as FAO Code of Conduct for Responsible Fisheries, CONAGO, which is the governor's coalition in Mexico, and so forth. And then with a number of workshops with fishermen and authorities, the results for each fishery. So I'm going to go very fast through this, including a very comprehensive analysis of the accomplishment of the Code of Conduct for Responsible Fisheries for each of the fisheries in Mexico, dealing with some 430 topics, components of the code, and evaluating each one for each fishery and for each region in Mexico. So the meeting with fishermen and authorities was also very comprehensive, with a good number of representatives and stakeholders from different regions. And they ended with approaching 3 major topics with the plan. One is the correction of structural problems within the administration of each fishery, such as overcapitalization and overoccupancy and overexploitation, of course. Also thinking on growth, because there are a number of resources, identified resources, or fishing areas that are underexploited. So there are potential resources. Mexico see a potential in inland fisheries, where basically fishing in the ocean. And of course the development of aquaculture to increase the production of marine protein. And competitivity, such as I was unable of translating this. I'm sure you have something in English. This is all the production chain from the resource to the consumer, and so each step you can improve the design of the change to improve the complete system and eco-efficiency. So the plan is aimed at taking Mexico up here. We've been stable in the fish production for some time. We think we can increase, and that's the goal of that plan. So that master plan sounds simple, but it's actually a very, very responsible plan. So they ended with a number of strategies for each fishery in each region. We are basically crossing those strategies with the potential futures that could occur or relate to climate change. For each of the fisheries here, there was an analysis of the production level, and upon of that, there was a number of decisions taken in the SWOT process. So we changed the original rules, and then we see what happens with the strategy. So first, we try to analyze or document everything we know about the forest species or fish groups and how they relate to climate. Things like this, some of them very basic, like distribution, and from there we can think of thermal limits. Some of them, they have very good ecophysiological studies. So rules are different for each case. So we build a number, with all those observations, a number of rules that if temperature increases this much from what we know could happen this with the overall biomass of that resource. And we are, of course, documenting the uncertainty, in some cases very strong, very high. The other thing is that we have to, by law, it's in the law right now in the climate change national plan, that we have to develop and use climate change scenarios accordingly to the IPCC scenarios. So we are doing that, but we're also including a little twist that it's evaluating how much we trust in the scenarios based on the trends of the data in the past, as much as we can see. So we are making a lot of retrospective analysis of the time series, and then using them to grade for different futures. This is 3 time steps in the future, how much we believe in them. For example, and I want to call your attention to exactly the place where I work most is the place where the models are totally untrustable. We combine those things in the adaptation plan. Basically, it's the survey of all the strategies and potential changes in the strategies or the strategies menus. We go with the stakeholders and ask them if they are logical, feasible, and they grade the strategies, and then we incorporate them and order them and prioritize them. And when we are supposed to transfer that, we're in this process. We are supposed to transfer that to the government again, and the government will decide how much they incorporate it into the actual policy or management plans. The law made them ask for the plan, but it's not totally clear to me, at least, how they will incorporate it in the actual management plans for the future. And of course, we have to monitor the success, not only changes in the environment to know what future is occurring. This is planned to check every 5 years what is the future we are observing, and so we can come back and decide which one of the lines or the potential menus is the one we're using. But also, once we take an action every 5 years, there's a way to evaluate the success of the action and reconsider or redesign or whatever, and come back to the adaptation plan. So adaptation plan, it's not a document that says what to do the next 100 years, but a different change of menus that that interact and change very dynamically according to these. So just a few take-home messages from the talk, particularly for natural scientists, but if you can consider this idea also for other areas, it would be great. One is avoiding the scientific consensus as a proof, deal with natural variable resources and synergistic effects, just incorporate variability in all your models and all your thinking on natural resources, particularly marine resources and living marine resources. And well, we know we have the duty of helping management and authorities by providing the best possible information. So we have to deliver that in a rapid, efficient way also. And for managers, probably some of you more in that area of knowledge. Of course, the linkages with this, that consider and use the best available scientific knowledge. Take the precautionary approach, and this is not fisheries precautionary approach, it's climate change precautionary approach. The costs of not, for managers, of think that there's no climate change can be very strong, particularly in some areas of the world. So the best way to go, or more responsible for some societies, is to consider it as a fact and incorporate it into management without leaving knowledge building beside. New management strategies must consider climate and climate variability and change. And we, of course, particularly southern from the border, we really need to improve our observation system. We don't have a time series of pH down in Mexico. There are very few, even in the US or in the North Atlantic as well. And these are similarly for temperature, for meteorology and several information needs that and variables that we have to monitor to talk about climate change. And I think I'm stopping there. Thank you. Yeah.
You do ask a question.
Yeah.
Thanks, Salvador. I guess I saw kind of an interesting paradox in two different things that you propose here. On one hand, you might want to choose management policies that are resilient or robust to the natural variability that you expect to see in the future. But on the other hand, if you do those things, you may not learn very much. So you may not be able to adapt in the way that your last few slides suggested. Help me think about that problem. I mean, should I pick things that allow me to learn, or should I pick things that are robust to a wide range of possible futures? Or maybe maybe there's some management instrument that allows us to do both.
Of course, you have a better answer to that than myself, but I would tend to think that the more robust or more, is that linked to classic management? Robust management frameworks?
I guess the question is, what sorts of management approaches do you think are going to become most relevant in light of these issues?
I would say that the thing would be very adaptive capacity, including a very, very strong adaptive capacity. That it's include monitoring as part of the decisions permanently. It may sound very trivial for some fisheries, but it's very important for others. And where we lack data, we make one biomass estimation, and from there we plan the entire fishery for the rest, the end of the time. So we have to keep revisiting and be able to change our rules just as dynamically as nature does. So we have to compete with nature in the changing rule capacity. I would say that that the kind of permit rights based management and and incentive-based management tend to be more dynamic and more easily changed than the traditional, management. Like, of course, this contradicts a little with the long concession idea that it's also very, seems to be very useful, but it all, again, depends on our way to think on management as a very dynamic process. I didn't respond at all. Yeah.
I would like to hear which are your suggestions for how do we face in the next years for the management of fisheries these whole problems about conflicts of interest in any fishery. For instance, how we deal with the conflicts in the food availability for communities or different countries. How do we deal with cultural differences between countries or communities? The same thing. Like, for instance, boundaries. How do we deal with that stuff? And how do we deal with conflicts of use of the shore of the ocean between countries or communities? And how can we integrate all that, as you say, there, like in a synergistic way? What are your suggestions in order to do that? And plus, since I was in Mexico last week, and certification is a huge deal. So how would you say to a fisherman that's already certified that his fishery is not sustainable? He's going to say, but I'm certified. Right?
Those are like 23 questions together. I would say for the first part, and it is very trivial, but the ocean has no boundaries. So when we think, particularly for transboundary resources, we have to think on the entire area, and we have to find a way to, to analyze and understand the fishery and its environment as a unit and not pieces of it. That's particularly, dramatic for some areas of the world. They analyze their fishery in latitude, and it makes no sense. And decisions have to be taken. There are at least technical decisions. Then the governments, how the governments deal with the information and interact with it, among them, it's sometimes irrelevant in terms of the technical information, but it's the best scientific available information may not make it to the final decision always, right? The second issue was
cultural differences. I mean, like, it's the same topic.
Yeah, I think this kind of exercises, like the IPCC report, and it's not the only one. One of the nice things they have is that they take a regional approach and analysis, and they talk about entire regions or systems instead of countries. So there you have a scientific platform, common scientific platform for the environment and potentially for the resources. Then you have to deal between how the decisions are made. Depends a lot on the countries. There are huge differences in the decision-making process. But no, the other second part.
Oh, the food availability. What if, in order to maintain a fishery, I have to diminish the food supply for a given community?
I would say you have no choice. Your only decision would be, I think, try to improve in other areas like efficiency or so forth. There's a lot of fish resources that are not easily or efficiently incorporated into the food consumption. So there's a lot of energy lost in, for example, burning anchovies or sardines in some places. So there's a little space for improving the amount of protein that gets into the people. And I would say the huge problem with food production, and it's not really the food production, it's the distribution. We haven't had as much food per capita as we have today in the past. The problem is that it's terribly distributed. So we have a lot of work to do in the efficiency of distribution and improving in those areas. And I think we have space to reduce catch in some species. Some fisheries that are demanding that. We have space for that because we have space, to contract with the distribution of protein. Yes, please.
So you showed a slide showing the overall fish catch going up in the future. I assume that some fisheries would have to grow and some would have to shrink. It's not uniform increase.
That was Mexico only, right?
Mexico.
Yeah, absolutely. And actually, it's a graph for politicians. So it's a graph for politicians, so they get excited. But most of it is aquaculture.
Oh, it's
Yeah,
aquaculture.
yeah. So there's again some chance to increase with good management, but for most fisheries we're at the top of the production, and recovering there's a small chance also, and potential resources it's really small. It's the big chunk is aquaculture production.
And is that freshwater or saltwater?
They're thinking a lot in freshwater.
Freshwater.
I would say that probably more than half is seawater. It's ocean, but so in biomass it's important, but in growth not that much. The big growth is thought for freshwater aquaculture, and not only aquaculture, but just putting seeds in an enclosed water body and fish from there. I don't know the term in English. Sorry. How do you call that?
Stocking.
The stocking. Okay, thank you. Yeah.
This is a good question. Why the plan was focused more on industrial fishery because of then think that we have in Mexico a good chunk of guys in artisanal fishery. So why it was focused more on industrial and all this, what's the proportion of artisanal fishermen can be incorporated in this kind of plan?
Okay. The plan, the master plan, is not only for industrial fisheries. It's for all the fisheries, all the most important fisheries. Dealing with artisanal fishery is really complicated because of the number of species involved in the catch, right? So this the cross with climate change or the adaptation plan is only for industrial fisheries because we're learning. We can't deal with a very complex fishery if we're unable to do it for a monospecific, highly fluctuating fisheries that like the industrial fisheries. Exactly, and the decisions are easier and so forth. But it will have to be done according to the law for all the fisheries, at least the fisheries that are in the master plan, in the fishing master plan. That includes a lot of artisanal fisheries and small-scale fisheries. And the other part of the answer is the most important fisheries in Mexico for biomass are industrial, but the most important in terms of people are, of course, as normally the small-scale fisheries. And there are some small-scale fisheries that are very valuable also.
What are these new management strategies that you think are going to be, we are going to start to see these new fisheries included in these kind of changes scenarios?
I would think that property rights schemes and variations of that will become more frequent in the management in general. In Mexico, there's a lot of cases that could turn to that in the next few years. So I think mostly through property rights, different kind of property rights. Is that the question? Yeah. Sorry.
It seems that we know a lot about the shift during the production system.
terms of climate change, well, part of the problem is that we use a lot satellite information that deals with surface, and global databases normally use surface temperature, so we know a lot about the surface, not a lot, but something about the surface in terms of environment, and less in the for the benthic environments. Another part of the answer would be that most of the pelagic fisheries change very rapidly with climate, are very strong responders. So we like the cases like sardine. We love sardines because they do that. They change very rapidly and very dramatically. Benthic ecosystems are, you have to monitor for many years and have, really strong events to have any signal. They filter a lot more efficiently the climate signal than the pelagic highly migrating fishes. So, I think that's also part of the answer. And of course, we don't have, that's the similar situation than artisanal fisheries. We don't have enough information, historic information for as we do for monospecific fisheries. So the kind of responses to climate in an entire community, or that it's fished as a multi-specific fishery, is very hard. Each species has a different answer or response to climate. So to have a single governing pattern to make a forecast or whatever, it's way more complicated. Yes, please.
You mentioned the climate change models have the largest error in the same areas where most of the fishing occurs. Just kind of wondering why that happened. The graph I shown was a primary production model, right? Depending on that comes from the climate model. That was the one with the dots. I would say that it happens in, I don't know. The answer is I don't know, but I would guess it has a lot to do with upwelling systems that are not properly incorporated yet in the climate models, but are of huge importance for primary production. So I think that they are missing that linkage. So in the climate, they shouldn't have primary production there, but we do. Thank you very much.
Just an announcement. We're